Assalamu alaikum. Uh, Welcome to the next chapter of the load flow analysis. And in the previous lecture, we come to the conclusion of this important result that II is equal to summation j is equal to 1 to n yij vj, where I is going from 1, 2 up to dash up to n also. Now we'll discuss the properties of the Ybus, how to detect directly whether some Ybus is a Ybus or not. The diagonal element of the Ybus gives the self-admittance. We can see it from here also. Here these y11, y22, y33, that's the self-admittance because we have defined them likewise. Y1 is this, that is the self-admittance of sum of all admittance, and these are the diagonal elements. The off-diagonal elements of the Y-bus gives the transfer of mutual admittance between the two buses. You can see it over here. The magnitude will be y12, that will be the admittance. It will give us the admittance of the buses, two buses, which are connected through some admittance. So the third one, it is a sparse matrix. We'll come to know shortly what does this mean. It means most of the elements of the Y-bus are zero. Diagonal elements will always be there, but sometimes you will see that if bus 5 is not in a 10 bus system, all the buses will not be connected to the all other buses, and when any particular bus is not connected to any other particular bus, the admittance between these two can be considered to be zero. And most of them, most of the buses will not be connected to the other most of the buses, so you will see the elements of the matrix will be mostly zero, and that is what it means by a sparse matrix. It's a symmetric matrix. That means this y12 or yij in general, yij is equal to yji, but provided this is important, provided phase shifting transformer is not present in the system. If it is present, then Y-bus is not symmetric. It is a square matrix because n into n, hence inverse is possible. The inverse of a matrix is Z-bus, impedance matrix, which is a full matrix. The inverse of a Y-bus is a Z-bus, and actually inverse of Y is itself impedance, that's admittance, and Y-bus also is a Z-bus, which is a full matrix. It is not a sparse matrix. In a purely imaginary Y-bus matrix, if we assume R to be zero of a transmission system, the off-diagonal elements are positive imaginary and the diagonal elements are negative imaginary. You can see that if only impedance reactance are considered for, let's say, transmission line, we know that admittance will be equal to 1 divided by some j into xl. It will be minus j by xl or minus j into some value of the reactances, some value of the admittance, sorry. So minus j will be there. So diagonal elements are positive, diagonal elements will be negative imaginary, and the off diagonal elements will be negative of the actual value. Since they are negative, negative will be positive, so it will be like this as per this point. When the shunt elements are added to the system, the only diagonal elements will be affected. If we have already Y-bus, now shunt elements are added, you will see that only diagonal elements of the Y-bus will be affected, but when series elements are added, both diagonal elements as well as shunt elements are affected. You can see it from here, this definition. When shunt elements are added, they will come into this. Sum of all admittance connected to the ith bus, and these are the diagonal elements. Diagonal elements will be affected. You will not see them in the mutual admittances. That is why the mutual admittances are off diagonal, which are actually the elements of the off diagonal elements of the Y-bus. They will not be affected. Now, if the series element, that is the line between two buses, are added or subtracted, you will see they will come over here. That means diagonal YII, and this also will be affected. This one more property, and the last one is sum of the elements of the ith row or ith column of a Y-bus matrix is zero if no shunt elements is connected to the ith bus. Now you can see it from here and just come back to this. You can see here y11, y12, and y1n. Let's just talk about y13. y11 plus y12 plus y13. When you add them here, y11, y12 plus y13. When you add them, this y12, y12 will cancel out, which is y13 and y13 will cancel. There remains only That's the shunt elements. That is what this means. If there are shunt elements, addition of these elements column wise or this row wise, this is the row wise addition, will result only in the shunt elements if they are present. If they are not present, it will be equal to 0. So that's what it means. Since it is symmetric, column wise it will also hold if phase shift transform is absent. The sum will be equal to the sum of admittance of the shunt element if present connected to the ith bus. If the shunt elements are not present, then it will be equal to 0. Let us try to do one numerical and it will be quite easy to understand it by this way. Let's say we have a system, we have bus 1, we have bus 2, and this is the reference one, 0. Here n is equal to 2 because we are always generalizing it here. N is equal to 2, 0 is the reference bus. There is a line whose impedance is 0.5, which is connected between reference bus and bus 1. Similarly, we have bus 2. There is a line connected between reference bus and bus 2 whose impedance is J0.2, sorry 1. So here Y11 is the total admittance connected to bus 1. That's only this line. That is 1 divided by J0.5, that is minus 2J. Similarly, Y22 is the total admittance connected to this bus, that is 1 divided by J 0.1, that is minus 10J. You will see there is no connection between 1 and 2. So admittance between 1 and 2 will be equal to 0. Because if you calculate the impedance between these two, 1 and 2, that is infinite, and admittance will be 0. That is Y21 will be equal to minus, sorry, Y12 is equal to Y21, that is equal to minus Y12, that is equal to 0. So Y bus will be equal to Y11, Y12, Y21, Y22, that is equal to minus 2J, that is this value, 0, 0, minus 10J. If I take this out from this matrix, it's minus 2, 0, 0, minus 10. This is the Y bus for this system. Let's try to do some more numericals. Find the Y bus for the following system shown below. Line admittance are marked on each bus. Sometimes you may not be given this information, that is this line admittance, but you have to identify it by the values given here, because this will give us idea about whether this is admittance or whether it is impedance. If the line is given by having positive sign before this J, then it is an impedance. If there is minus sign before this J, then it is an admittance. Here it is a minus here, that means it is admittance. So this is the admittance of the line which is connected between bus 1 and 2. This is the admittance of the line connected between 2 and 3. Similarly, this is the line connected between 3 and 1. So here n, that is the number of buses, is 3. So Y bus can be written as Y11, Y12, Y13, Y21, Y22, Y33, Y31, Y32, Y33. So diagonal elements, that is first Y11 is the total admittance connected between bus 1 and bus 1, that is these two lines, and we add them, it will be 4 minus J5, that is minus 1 minus J2 plus 3 minus J3, that is 4 minus J5, that is still this. Y22 is the total admittance connected to bus 2, that is this plus this, that is 3 minus J3, 3 minus J3. Similarly, 3 that is why Y33 is equal to addition of these two, that is 5 minus J4. Is it so? It's like, yes, it is 5 minus J4. Similarly, Y12, that is the transfer admittance or mutual admittance between 1 and 2, that is the negative of this, that is minus 1 plus J2, that's minus 1 plus J2, that will be similar to 2, 1. So Y23, which is equal to Y32 is equal to minus times of this, that is minus 2 plus J, that is given as like this. Similarly, Y31 and 13, that's given as minus of this, minus 3 plus J3, that's it. And when we put it in the Y bus, it gives us this type of the Y bus. Sometimes this is very simple. It is known as calculating Y bus by inspection directly. It's very simple. We have derived different formulas, and then by doing it by the direct inspection, it is very simple. And here we are assuming that there is no mutual coupling between the lines. These two points are to be taken into the account. Now we may do some more numericals. The Y bus of a power system is given as like this. The Y bus is given already from there. If the line between 1 and 3 is disconnected, the line between 1 and 3 is disconnected, the new Ybus will be, how this new Ybus will look like. Before going to do that, I will try to explain this. You can see it here. It is an imaginary Ybus. Here only there are imaginary quantities. You can see diagonal elements are negative imaginary and off diagonal elements are positive imaginary. That is what this point was trying to tell you. So I hope this is also more clear from this point. Now from the information of this Ybus, I can draw the network like this. Since it's a 3 cross 3 matrix, I can draw a 3 bus system over here, 1 bus, 2 bus and 3 bus. And this is the admittance connected between bus 1 and bus 2. That is 1 and 2. I have written a minus 10 of j because this is minus times of this. I have to revert it back to actual minus. This is minus 10j. This is the admittance connected between 2 and 3. 1 and 3, sorry, this is 1 and 3. This is bus 1 and bus 3, that is minus j5. This is j5, this is minus j5. Similarly, this is 2, 1, this and this will be same. And then 3, 2, these two. 3, 2, it is again plus 10j, here it will be minus 10. This will be our power system. First, let us try to find out whether shunt elements are connected or not. I have told you that one of the properties of the Ybus is that if we calculate the sum of the elements of a row, it should be 0. If it is 0, then the shunt elements are absent. You can see minus 50 plus 10 plus 5, it is minus 35. That means shunt elements are present. Now this is the actual power system whose you can say Ybus is given like this. Here we haven't calculated the shunt admittance, we just know the shunt admittances are there. This is Ybus 1, sorry, this is bus 1. There are 2 shunt elements, bus 2. There is also some shunt element because this is not also equal to 0, this is not also equal to 0. All have the shunt element. I have not shown it over here, but from this you can calculate it. There are shunt elements present over here also. So when the line, if a line between 1 and 3 is disconnected, this line is disconnected, that means the admittance between now 1 and 3 will be 0 because this is disconnected, this line, it will be 0. But this I have shown it to connect this with, this is connected to this bus, this is connected to this bus. It will not have any effect to the shunt elements, only series. This line is disconnected. So we can say that y13 will be 0, which is same as y31. This is y13, y31 is equal to minus 1, this is equal to 0 for new bus. Old bus it was equal to minus g5, which I have shown over here. And what is the important thing that I have told you earlier, that since the line is disconnected from 1 and 3, so this is the series element, diagonal as well as off diagonal elements will be affected. Now which elements will be affected? You will see the diagonal element y11, the diagonal element y13, and the off diagonal element y31 and y13 will be affected. You can see the others, this line will not come in other terms of this Ybus, so they will be unaffected, like y21, y23, y22, like this. You can see here y22, this and this, they will not be affected. Which are effective? y11, y33, y31 and y13, they will be affected. So let's calculate it first, what will happen to this. So this is the same. Old bus y11 was equal to minus g10 minus g5 plus y120 plus y130, that is this, minus g10 minus g5 plus y120 y130. I have shown it like this. It is given to be equal to minus g50 in this matrix. So this will be like this. So y120 plus y130 is equal to minus g35. We have calculated. Similarly, y33 will be equal to y130, y310 minus g10 minus g5. That is given as to be, sorry, minus g25. So when we equate it minus g25, that is y130 plus y230 will be equal to minus g. For new bus, now y11 is equal to, there is not this line, it will be equal to this plus this plus this. So it will be y12 that is this, plus y120 plus y13, that's minus j10, that is this value, and the value of this will be minus j35, that's equal to minus j45. This is the one element. So y33 will be equal to y23, that is this, y23 will be this, and these two shunt elements, y130 plus y230, that's minus 10, minus 10, minus 10. So we have already calculated these two. Y13 will be this, that will be equal to 0. So this will be our new bus. That's minus 45 from here, minus 45j. Then these 5 will be unaffected. This will be 0, this will be 0, and this will be minus. So this is the new bus. Let us try to have uh, look at the more numerical, which may be asked in different ways. You can see over here, find the Ybus or the following system. Here you can see the sign of this J is plus, so it will be definitely impedance. Line impedance are given as per unit, it is given in per unit. So we have to calculate Ybus for this system. So first we'll calculate Ybus. Now if the impedance of this 0.05 plus J0 is connected, one more is connected between 1 and 2 here. One more line is connected between 1 and 2, find the new Ybus. That is actually homework. First we'll calculate Ybus for this system. So to calculate Ybus, we'll first calculate its admittances. So admittance will be simply inverse of this. So the inverse of this will be like this. You can calculate the inverse of impedance of all the lines. You will get these admittances. So you can see it here. Now J is having a minus sign. So simply Y1 will be the summation of these two. That is 2 minus J9. Sorry, 3, 2 plus 3 is 3, 2 minus 3 minus J9. And Y12 is equal to minus 2 plus J6, minus 2 plus J6. Y13 is equal to minus 1 plus J3. Y14, there is no connection between 1 and 4, that is 0. That's what sparsity means in this case. It seems that there is only 2 0, but when the number of buses increases, the connection between different buses is difficult, and there we will have 0. Y22 is the 3 lines, that is 2 plus 1 is 3 plus 2 by 3, that is minus 11 by 3, minus J11, that is 6 plus 2 is 8 plus 3 is 10, minus J11. 2 1 is same as that of this, and Y23 is this, minus 2 by 3 plus J2, and Y24 is minus 1 plus J3. This is Y31, that is this one, minus 1 plus J3. Y32, 2, that is this, minus 2 by 3 plus J2. Y33, that is addition of these three, 1 plus 2 is 3, 3 plus 2 by 3 is minus 11 by 3, and then this 3 plus 2 is 5 plus 6 is 11, minus 11J. And Y34 is this, is minus 2 plus J6, minus of this. Similarly, for Y4, 1 is 0, there is no connection. Y42 is minus 1 plus J3, Y43 is minus 2 plus J6, and Y44 addition of these two, that is 3 minus J9. So this is the Ybus of the actual system. Now, what is the modification? What we have one more line whose impedance is given as like this, minus this 0.05 plus J0.01 is connected between 1 and 2. Now you have to calculate the new Ybus. So first you have to identify which elements of the Ybus will be affected, and then calculate these. I will see this this Ybus modificative Ybus in the next class. Okay, thank you.